Welcome to our show. When sunrise and sunset are eternal, a glimpse into the surprising world of exoplanets. Over 30 years ago, even the smartest on Earth could not be convinced if any planets ever existed beyond the solar system. The first planets in another system were confirmed in 1992, and in a mere 3 decades, we are confident that the sublime Milky Way not only showcases billions of stars, but also houses billions of planets. In our solar system, the Sun is the bright star, and the Earth and other planets are orbiting around it. The planets beyond the solar system do the same, orbiting around their star the same way Earth orbits the Sun. Scientists call them extrasolar planets or exoplanets. According to the statistics of the Exoplanet Archive at the National Aeronautics and Space Administration, or NASA, among the billions of exoplanets, over 5,700 exoplanets in 4,289 planetary systems are confirmed, with 962 systems having more than one planet. Incredible, isn't it? We are incredibly fortunate to be able to observe from our Earth home the glorious celestial assembly of exoplanets and galaxies created by the immense love of God.
There are many kinds of exoplanets. There are small rocky ones, kind of like Mercury or we hope like Earth. There are large ones that are more gaseous, like Jupiter or Saturn. There are also exoplanets called super-Earths or mini-Neptunes that we don't even have analogs to those in our own solar system.
So we found a bunch of planets that are terrestrial in that they're the size of the Earth, they're roughly the same mass of the Earth as well, but they aren't true Earth twins just yet.
When we think about searching for life elsewhere in the galaxy, we can't go to these planets and test them in person. And so we're stuck with trying to study other details of the planets, things like their atmosphere or what we think the planet itself might be made out of.
Scientists managed to find several different ways to look for exoplanets, making use of radio velocity, gravitational microlensing, and direct imaging, among others. Most exoplanets are found with the transit method, which captures the change of light when an exoplanet passes between the telescope lens and the star it circulates.
The most common method is to look for an eclipse or transit as a planet passes in front of its host star. This is how the Kepler Observatory found planets, by staring at a large region of the sky and waiting for planets to pass in front of their stars, taking snapshots every second. The Transiting Exoplanet Survey Satellite uses the same technique on our nearest neighbor stars.
Each exoplanet is a unique story. An exoplanet named WASP-39b, for example, has brought us a number of surprises. WASP-39b is a giant exoplanet orbiting a remote sun-like star 700 light-years away in the Virgo constellation. As a giant planet, it has a diameter 1.3 times greater than Jupiter and a similar mass to Saturn. Unlike the cooler, smaller gas giant in the solar system, WASP-39b orbits very close to its star, only about 1/8 the distance between the Sun and Mercury, thus completes a circle around its star in just 4 Earth days. The near distance also makes the planet extremely hot, reaching 900 degrees Celsius in temperature. One thing about WASP-39b that excites scientists is its gas-rich atmosphere. Since its discovery in 2011 by the Kepler Space Telescope, water vapor, sodium, and potassium have been observed on the planet's atmosphere through the scrutiny of Hubble and Spitzer telescopes. In 2022, a year after it became the first exoplanet to be examined by the James Webb Telescope, the presence of carbon dioxide in WASP-39b was confirmed. On Webb's near-infrared spectrograph, a small hill between 4.1 and 4.6 microns, unmistakably presents the first clear, detailed evidence of carbon dioxide ever detected in a planet outside the solar system. Something scientists always look for.
We are looking for the kinds of gases that are produced by biology on a planet. For example, oxygen, carbon dioxide, water vapor, all of them together can be a sign of biology.
How did scientists uncover the secrets of an exoplanet's atmosphere from so far away? It's no mystery. The research team used the highly sensitive near-infrared spectrograph on the James Webb Telescope to observe the exoplanet. This powerful instrument captures not only visible light, but also a range of invisible wavelengths from the Sun-like star. As the exoplanet orbits, the star's light passes through its atmosphere, carrying valuable information all the way to the telescope on Earth.
As light is traveling through the planet's atmosphere, some wavelengths get absorbed. Which wavelengths get absorbed depends on which molecules are in the planet's atmosphere. For example, carbon monoxide molecules will capture different wavelengths than water vapor molecules. So when we look at that planet in front of the star, some of the wavelengths of the starlight will be missing, depending on which molecules are in the atmosphere of the planet. Learning about the atmospheres of other worlds is how we identify those that could potentially support life.
The surprises of WASP-39b don't end there. So far, 5 research papers have explored this fascinating exoplanet. Published in Nature, the latest discovery based on observations of the Webb telescope reveals a perpetual atmospheric difference in this tidally locked world. Because WASP-39b is tidally locked to its star, the atmospheric differences between morning and evening are constant. In other words, WASP-39b experiences an eternal sunrise and eternal sunset, just as scientists had predicted. Are you thinking, wait, what does that mean? First, let's make sure we understand tidally locking. Tony Darnell, host of Exoplanet Radio, has a clear explanation ready for us.
Tidally locking is a phenomenon that occurs when a planet rotates at the same speed as it orbits its star, so it always shows the same face to it. This happens when the gravitational pull of the star is stronger than the rotational force of the planet, and it causes the planet to slow down until it reaches a stable state. You might be familiar with this effect from our own moon, which is tidally locked to Earth and always shows us the same side. But what if a planet was tidally locked to its star? Well, that would create a huge contrast in temperatures between the two sides of the planet. The day side would be constantly exposed to the star's heat and light, while the night side would be in perpetual darkness and cold.
Just as we start to grasp the idea of eternal sunrise and sunset, another fact about WASP-39b blows our minds. Contrary to what we'd expect, the evening side of WASP-39b is a scorching 200 degrees Celsius hotter than its morning side. This new analysis builds 2 distinct spectra from the border regions between the planet's day side and night side, splitting them into 2 semicircles. When the data is combined, it reveals a startling difference in temperatures between the hot morning and the much hotter evening. So, what's causing this extraordinary phenomenon? Astronomers have pinpointed the culprit, WASP-39b's gas circulation. As the exoplanet orbits its star, hotter gas from the day side sweeps through the evening toward the night side via a powerful equatorial jet stream. The extreme temperature difference creates a significant air pressure difference, leading to intense wind speeds. This finding becomes a benchmark for other exoplanet studies. The story of WASP-39b has just begun. Remember, it is one of the billions of exoplanets in the Milky Way we cannot set foot on, even with our most advanced spacecraft. Yet, we are incredibly fortunate to be able to observe and marvel at. We ought to be more grateful to be able to identify ourselves as the Earthlings inhabiting our precious Earth, the small but invaluable beautiful blue marble in the myriads of stars and planets in the universe. Our Earth faces critical challenges that require immediate action. To protect our planet and all living beings, we must address both climate change and the harm caused by livestock rising. The choices we make today will determine the future of everything we cherish. Now is the time to embrace a more compassionate lifestyle, foster peace, and seek divine guidance as we work together to safeguard our world.
Vegan, very positive attitude.
Truth-loving viewers, thank you for your precious company in our show today.